Well, can you give us a 4,000-foot view of what LayerBlocks is?
So LayerBlocks is a software generator for generating different variants of products in the same product line.
So you want to be able to generate all of these variants. How does your generator actually work? What does it take as input, and how does it process that?
That's a good question. So I should say first off that our generator is based on a pretty well understood idea from software engineering that goes back to, it really goes back to the early 90s on product line generation. And so each variant that we want to generate is a different program in the same product line. And we organize our product lines in terms of reusable features that we put into a library. We've designed them according to a design idiom that makes them very composable with one another, which I'll demonstrate here in a little while. And what you do then to generate a variant is you write something called an assembly specification. An assembly specification explains how you put these features together in some novel combination to generate a particular variant. And it has some particularly useful properties, which I think we'll be able to dig into by example here in a few minutes. But what's really nice about it is the features you can write once and reuse many times, and you can very easily understand, by virtue of comparing these assembly specifications, how two different variants in the same product line are common and how they differ, and be very precise about that.
And I'm curious about the title LayerBlocks. Is this related to layered architectures?
It is. It is. When you see some examples of assembly specifications, you'll see that the components that we're generating, each component, when I use the term variant, I mean program or component. So when you see how a given component is generated, you'll notice that it's the little program you write to say how to generate it, the recipe, is a very layered, very hierarchical form. It's related to layered architectures in another way too, in the sense that typically with layered architectures you tend to think of software built in stacks where you can understand a layer, you can understand one layer just in terms of the interface that it exports without any knowledge of how it's implemented or of the layers that are underneath it. The assembly specifications that we write using LayerBlocks have that same property.
And just to clarify a bit, the layers that you're talking about and the generated code you're talking about, they go in that middle tier?
No, they actually, in this case, they could go in the middle tier, but in this case they go down in the data tier.
Okay, so the tiering is kind of independent of the layering.
That's correct. That's correct.
And in the diagram, there's also this reusable feature library. Can you say a word about that?
So, I mentioned earlier that when we have a number of different clients, their programs and their applications are very similar, but they're not exactly the same. What we found is that if we do a decomposition, a design of our software by feature, and I know you guys have spoken of feature diagrams and feature modeling in the past, when you do a feature-based design, you actually can get reusable pieces of, they're not whole applications, they're little fragments, but they're highly reusable and composable in ways that you can put them together to make different variants of the same application very easily. So we did in the example we'll see, we basically did a feature analysis to understand what are the different features that are put together to do forecasting. And based on that feature analysis, we designed our reusable features around it and got this ability to compose them in this very, very nice way.
So the unit of variation is a kind of a customer visible feature?
It may not be customer visible, and ideally it could be, right? And in other product line work, it is the unit of the unit is customer visible feature. In our case, it's more implementation centric, but still, it's much more on the science side than the customer side. So in our case, we're doing forecasting, and there's some pretty complicated algorithmics that go with forecasting. So that domain is the domain at which we've done the feature analysis.